How many of you, by the way, have ever read like the Little Bobby comic? How many of you do that? Yeah, a couple of you? Good. Remember though, I am the writer of the comic. I am not the illustrator. So I'm going to draw, but just keep that in balance. It seems impressive, I think, to draw, but what it really boils down to is I suck at making slides, and I always forget to make slides, so it's just easier to show up on stage and do this. But anyways, the talk today is really about this discussion between threat hunting and threat automation, and obviously threat farming is the sort of the piece that we're putting for that. And this debate extended a couple years ago, and Alex and I actually had kind of a dueling conference talk at the CTI Summit, where he made the pitch for automating threat hunting, and I made the counter pitch of, I'm sorry, you can't. It's around the human-driven, hypothesis-driven kind of approach. And then, of course, here we are today coming together to try to have a better approach, which is a nice little blend for everybody. So starting off, I want to list a couple important concepts and make the pitch on what exactly is that definitively human kind of approach. And this is very much an idea talk. This is not one where we're going to throw a bunch of command prompts, but it's a talk that I think is good considering your own security operations, your own incident response, the only ways that you go forward and do this next year. So,
yeah, I think we should just flip the slides to where you actually start talking, I guess.
Do you want to do that?
Yeah, sure.
I'll go for it, Alex.
Yeah,
always making things difficult.
It's like there's too much going on right now. Just got the papers, we got the slides, we got the camera. So, I mean, I just want to make sure, I mean, that's the title, right? This is who we are. This is actually who we are. This is our actual day jobs right there, right? And I just want to make sure that, and I mean, I think Rob did a great introduction. This has been about a struggle, right? We have been arm wrestling about this for a very, very long time, right? And my belief is that, and this is usually where we come down to most of the time, is around terminology, right? When I use some words, and then Rob gets pissed off with me because that's not how you use that word. That's not what that word means, but we're just coming from completely different perspectives. Right.
He's wrong, I'm right. Yeah.
So one thing that I specifically remember from our discussions was that I always told him that his definition of threat hunting was always very cyclical, as in threat hunting is actually the act of humans finding what automation missed, right? And I'm like, hold on a second. What if I find something and then I automate it, but it's like a super complicated threat hunting-ish kind of thing, right? Suddenly it's not threat hunting anymore, right? Suddenly it's just automation and it's not hunting. So this is where we usually had most of our disagreements.
And nobody should actually listen to either one of us on like words, because English is a second language. I'm from Alabama. English is a second language. Like words are difficult, folks, but I think it matters. So yeah, perfect. You want to jump into it then?
Yeah,
we're like Bert and Ernie up here,
I guess. So I guess the main point that we had, and as we were talking through this, is that I guess the main part was for us trying to find this boundary, right? And we came across an interesting concept that I want to talk to Rob to expand a little bit about the difference between actual strategic threat hunting, right? And something that's a little bit more technical, right? So Rob, because of his background, usually thinks of things more strategically, right? He has a lot of intelligence background as well, right? And I'm a data guy, right? I like to get my hands dirty on the data. I'm always concerned, like, how can I extract value from these things? So I always have this kind of a bottom up while he's coming from the top down. So this is the slide where Rob talks about all the strategy that he.
All right. And then Viv hasn't started the clock yet, which tells me that we get to speak for a couple hours.
Yes.
So we're gonna be here for a little bit. Anyways, so let's explore this concept. To do justice by this discussion of threat hunting, I want to introduce a couple other concepts. You might have seen me give presentations on them before. If you haven't, they're available online. But generally speaking, when I think of threat hunting, and we'll get to that kind of discussion on threat hunting in a second, I put it into this context of like 3 different ways to generate these hypotheses. And Bianco and I had a nice SANS paper about those 3 types, which was effectively domain expertise, it was situational awareness, and it was intelligence. The 3 different forms of hypothesis generation. In other words, I might have done this so many times before that I'm good at doing this, but just saying like, oh, it just came to me in a dream is not any bit scientific. It's this discussion of I've seen this before, therefore I now know that I should go hunting for it. Situational awareness can be anything outside of the discussions of just purely technical components. It might be this idea that I have a power company, they're acquiring a gas pipeline company, and my hypothesis is because of that acquisition, they're already compromised. I'm going to see lateral movement through a VPN getting connected in, so I'm going to go hunt for what I perceive to be adversary activity moving into my environment based on the situation around us. And then intelligence-driven can be both friendly and threat intelligence. But this is actually where a lot of us put our focus. So even though I come from more of an intelligence background and like that component of hypothesis generation, just know your own gaps. If you're constantly coming up with intelligence-based hunting, you should then try to flesh out your skills to go more towards situational awareness. Also look for things that have occurred before from domain expertise. But the other thing that I think is important is this concept of CMFs, activity groups, analytical coverage, and environmental coverage. So let's go through those really quick. One of the things that I think a lot of companies and organizations should start doing a little bit better if they're going to go forward and do hunting is having a pretty decent understanding of their environment. That's kind of table stakes, and we all say that. We say, oh, critical control number one, have an asset inventory. But I find as I go to companies and I ask them what's in their asset inventory, and they're like, oh, the firmware level of our devices. Like, cool, what are you using that for? Like, I don't know. It's in our asset inventory. We're supposed to have that. I'm like, but how are you actually making that useful to security? Rob, stop it. It says right here on the checklist, I need to have firmware. I'm like, okay, man. So what I prefer you to get in the habit of is kind of an asset inventory with a purpose towards security operations and incident response. A lot of asset inventories that have previously existed had more of a product security focus of, let me go patch vulnerabilities in my inventory. So if we're going to be doing hunting, I want to go a little bit further than that. And what I would request and kind of put forward is I should not only have, I told you I'm not the artist, what I'd prefer you to have is almost a matrix of what do I have, sort of where is it, and so I might say that this is and I'm an ICS guy, so I might have a human-machine interface outside of a distribution level substation. And so you'll go through and say, where are these devices actually located? What am I actually talking about? You'll go through and then you'll say, okay, well, what is it? Like I said, it's an HMI. Like, all right, well, what type of data can I get off of it? Well, it comes with like the Windows logs that are actually on that HMI. Okay, well, how long am I storing it? Well, I have 30 days of those logs. And cool, where can I go to next? Where can I pivot? Well, if I really needed, I could also do a memory sample. Like, okay, and then because I didn't draw enough logs, I might also say, well, great, what type of questions can I ask of that data? And I might even just break it down in like a kill chain. You can use attack or whatever else on what types of questions am I going to ask of this data. And later on, I might even be able to hotlink those into playbooks that I make as a result of my hunting for other analysts to then follow along. And in doing this, as I go through my overall environment and see like RTUs are basically your field devices at that same substation, I see that I have domain controllers at the control center. I start going through and filling out everything. What I really want to get to is an ability to then start hunting across this data. And so I might take an activity group, which are different than threat actors. That's another presentation out there. But effectively, the basic way to think about that is threat actors, like APT29, is a discussion of who. It's an attribution discussion. Not necessarily Rush or whatever else, but it's an attribution like, this is APT29. And as things change, there's value and there's different intelligence requirements and constantly tracking APT29 over the years and seeing all the things they do. Activity groups are a discussion of how. And so they're purposely bound to the diamond model, which is effectively just what's the tradecraft, what's the infrastructure, and what's the victimology. And as those things change, I'll actually do a new activity group because I want to have a bounding that I can then tell somebody, I want you to protect against, Electrum, and that means something to you instead of having follow-on questions on, well, what year, what malware, what victim, what other things about that threat actor. In other words, threat actors from a defense standpoint have too many follow-on questions to be useful, in my opinion, to defenders, and activity groups can kind of clump that a little bit better. So I'll take an activity group and look for the tradecraft that they're accomplishing, and I will end up turning that into an intelligence-driven hunt. I'll say, okay, well, if my activity group were going to compromise us, and I were to go hunting for them, would I be successful or not? And so before you ever do the threat hunt, which is human-driven and very intensive, it is a time-consuming component. Before I ever go do that, I could look at my collection management framework and go, well, if they were going to compromise us, here's where they would compromise us. Here's the tradecraft we've seen before. And I can go through and bounce around and go, well, actually, we don't have the data to actually validate that hunt. We will never be successful based on the data we're collecting today. So I can avoid hunting, which is one of my big pitches around threat hunting in general, is make sure you avoid it at all costs if it's going to waste a lot of your time and resources. Don't go on a hunt that you couldn't ever return any value to your organization in the first place. And just looking at this, I can go, oh, well, we need to increase our logging here. We need to go from 30 days or 7 days here to maybe 30 to match it across. I'm going to start getting an understanding of that environment and that ability to hunt. But then I also want you to consider analytical coverage and environmental coverage. Environmental coverage, the easiest way to think about that is when somebody hands you an indicator and then you put it into the SIM and you hit search and nothing comes back and you go, turns out I'm not compromised. We all know there's a problem there. The problem is you may not have been collecting the data from the portions of your environment that could have ever returned a positive answer in the first place. So that indicator suite means nothing in your organization because you don't understand your environmental coverage. You should have a good understanding that, well, across all of my security architecture, I have these devices that give me this coverage, this device that has this coverage, here's my gap, which means only 65% of my collection could even return a positive answer on the question that I'm asking. And then you'll get to an analytical coverage, which goes and says, all right, well, I'm looking for a specific threat in my environment, but I'm looking for one aspect of their tradecraft. And this is where I think the machine learning AI kind of discussion, obviously used interchangeably because machine learning and AI is the exact same thing, right? No, okay. This is where I think there's a little bit of mischaracterization when someone will go, well, how are you going to detect the unknown unknowns with tradecraft? Because unknown unknowns haven't occurred yet. You're like, and I don't know how many of you have been in these product pitches, but it gets quite religious with folks. We're like, well, only machine learning can detect this because you haven't observed it before. And that's actually a misunderstanding of analytics and kind of the tradecraft focus, which is as I have an adversary's kill chain, there you go, that magic word again. As I have an adversary's kill chain, I don't really care about detecting every component of everything they do. I care about having analytical coverage or tradecraft coverage to say, if they do this step, I got it. If they do this step, I got it. If they do this step, I got it. They might be novel in 1 or 2 or 3 aspects of their attack, but they're not going to be novel in every single step. So it's not like I have to have machine learning to then go and detect anything. I've got to be reliable in my detection in one location. And then I pivot the investigation and see everything else.
And look for the other stuff.
It's this discussion that through analytical coverage, defenders actually have that upper hand. This old adage of, well, adversaries only have to get it right one time and defenders have to get it right every time is stupid and is a product pitch, and you must move backwards from that and realize that you just have to detect one thing reliably and you'll be fine. So how does that relate to hunting and kind of what we're talking about? So let's do an example, and then he's going to go through kind of where the machine learning piece is. I would put forth the evaluation of my environmental coverage, my analytical coverage, the development of the tradecraft hypotheses itself is distinctly human. I'm going to use automation. I'm going to use a lot of things that help me scale that out. But I'm sitting down, identifying what's going on, doing intelligence analysis, and then creating that hypothesis after the fact is the human component. So let's take a tangible case study that happened this past year. In 2017, there was an attack in a petrochemical facility in Saudi Arabia. That attack was used a piece of malware. FireEye called it Triton. My firm, Dragos, called it Trisis. We actually didn't coordinate. Yeah, I'll bring it down. We didn't coordinate ahead of time. It wasn't just being competitive on names. It's just we didn't know each other were tracking the case. Either way, I'm going to refer to it as Trisis from here on, but you might have seen that. For some reason, DHS then got involved and said, we're going to call it Hatman, which I don't understand why, and we're going to do away with that. Good job, DHS. Anyway, so Trisis effectively had a very simple MO, very, very simple way that the adversary used this. In a petrochemical environment, you might have your enterprise IT environment, and we're just going to say that that's a big abstraction of filth that I don't want to touch my ICS, because obviously the IT stuff is worse. Anyways, but going into my operations technology or ICS networks, I then might have a VPN from enterprise into IT or into OT, and then once I hit that VPN, the adversary effectively popped over. If there was a domain controller, they went after it. Then they did lateral movement over to the engineering workstation, which is where I would program the equipment, actually introduce new logic. And off of the engineering workstation, they'd look for a safety instrumented system. A safety instrumented system, easiest way to think about this, is it a piece of equipment in an industrial environment that only exists to protect human life. That's it. Doesn't protect equipment, doesn't prevent outages, doesn't do any of that. It's just there in a dangerous process so that people don't get killed. So something goes wrong, even a cyber attack goes and takes place, the safety system kicks in and maintains the quality of human life. The adversaries specifically went after that. The only purpose to go after that is you're intending to kill people. This is the first time in history an attack was intentionally designed that we know of to try to kill people. Luckily, they made a mistake, but either way, the tradecraft of this is pretty simple. I don't need indicators. I don't need any sort of understanding of the malware at this point. I just need to know that anytime anybody VPNs into my OT environment and does lateral movement over to engineering workstation and then lateral movement down to the safety system as I'm pulling off logic of a safety system, that's a behavior that I can now look for and understand that it's been associated with these types of attacks before. Anyway, so that's exactly what we did, is came up with this understanding of tradecraft around this. And we said, look, this is our intelligence-generated hypothesis. This is the piece that automation and machine learning is not going to come up with to say, this is what I want to track for this purpose as it's been associated with previous activity, and here's why you should care. After this, though, we ended up taking that tradecraft and looking at other places around the world. And if you would do indicator checks and all that other stuff like many did, you'd get nothing. Why? Because the malware will always be different. Each safety instrumented system is uniquely developed and configured at that site, because it's for the physical process that's there. So everything about it's different at every single site in the world, even if the vendor name, like Schneider or whatever, is the same, it's a different safety system. So the same malware would never work on each one of those. I have to develop new capabilities, even if they're similar in nature, for each one of these. So a lot of people did the indicator suites, found nothing. We even saw vendors come out and say, here's a tool to check your safety system. And if you run this and check it, you're good, except for it literally would never work anywhere. And I have a little bit of a problem with people doing that. But anyways, so we went and tested for this tradecraft at other sites around the world, and we found the same activity group at multiple locations throughout the world, not just the Middle East, including one that ended up getting leaked here in the United States. The problem with that is it also introduces a whole political discussion of what happens if we have not mass casualties, but 20 people die in the US to a cyber attack. Like, how does the government deal with a small, isolated event? And unfortunately, there's not a clear answer. But the idea was, I'm going to more strategically, more operationally think about that tradecraft and then create that. Outside of that, there's no reason that machine learning or something else couldn't have then procedurally generated those tests, that is, those hunts, if you will, throughout all of these other environments. I would still not call them hunting, but this is where the transition of the talk is going to take place. I wouldn't call it hunting, but the procedural generation and scaling of that hunt after the first time is then going to be core to making it accessible to everybody, because I can't have people and you can't have people flying around every site in the world testing those things. But we've exhausted any discussion around indicators with certain types of attacks. So as we go forward and think about, well, how would you procedurally generate those hunts-ish, now we'll kick it over to Alex to talk about how he would do that.
I will win you over eventually.
One day you might.
Can we flip to the slides again, please? And I think this is the important point here. And I think Rob touched on a lot of very important points around setting up the scene, right? So this is what we want to do, but actually making it operational is usually a heavy lift, right? And there are two things he touched on, which I think are very, very important that I do want to reference here, is both the environmental coverage and the analytical coverage, right? These are the two main pieces that we all need to work on in order to be able to automate, right? Environmental coverage is very hard to automate, right? Someone has to go there and collect the logs, right? You cannot teach the machine to just give you, you can, configure a GPO. There's all sorts of ways for you to try to configure that, but someone has to take that action, right? The machines are not gonna just volunteer logs for you, right? And there's absolutely nothing you have to do about that, right? Even something as simple as patch management, right? Once we started automating it a little bit more, I remember the turning point for me as a fledgling consultant analysts when WSUS came together from Windows, and suddenly it was way, way easier. Even though it didn't help everything, it was already something that we started automating. So what does this technical part of, operational part of threat hunting looks like, right? So first of all, a magic thing appears, which is our normalized telemetry repository, right? And that's where we're talking about the specific environmental coverage, right, that Rob was saying, right? On the other point, we have the TTP repository, right? That's where we store our technical hypotheses, if you will allow me to call them that, around the activity groups that he was talking, right? That is where we're hoping to have some interesting analytical coverage, right? I mean, I know enough, right, based out of this diagram. I know enough of these things that I am not completely lost if one of those things happen. And then I'm just trying stuff out, right? Let's see if this analytical coverage that we have is going to find things there. And then again, a lot of work has to happen on the analytical coverage, on the environmental coverage, for us to be able to move this forward. But then the question becomes, can we make some magic appear here, right? If we understand what is I know I'm going to be searching on direct and indirect matches on threat intelligence, right? I have identified information on threat intelligence from that specific activity group, things they have done in the recent past. Maybe I can start searching for those, right? Maybe I can start searching for if something is rare or if something is very frequent inside my environment, right? These are all levers I can use to write a rule, right? Or is this, oh, I really, really hate this data center, right? This is a bulletproof hosting place, right? No one can get anything taken down there. So anytime someone goes there, maybe it's a little bit more interesting, right? These are all things that are easily describable, right, as analytical actions, right, as things that you can write TTPs of, and that should be present on your telemetry repository, or things that you can potentially search on, right? And the hard part, and again, anybody could be able to write those, right? But the challenge becomes, what does good look like, right? You want to try to have something that always has a low false positive and a low false negative rate, right? And those things are always fighting against each other, right? So I'm going to like one of my most favorite things in the world is anomaly detection. Anybody who has ever seen a talk that I've done, I think anomaly detection is the worst idea that ever happened for information security. But we're still trying to rehash that idea. Every 5 or so years it comes back again, and it has been for the past 30 years, right? An idea that has refused to die. So anomaly detection is a technique that it's very, very, very false positive prone, right? Because it's very sensitive. But on the other hand, it becomes super good on the false. It's not a lot of false negatives. I mean, it's going to be chirping all over the place, right? It's going to catch things, right? More often than not, right? But on the other hand, if you have a very well-curated threat feed, right? You have the Rob threat feed, whatever that's called, right? He like weaved himself from his beard hair. It's the best threat intelligence there is, right? And you're matching against that, right? That's something that's going to have a very, very small false positive ratio, right? But there will be an immense false negative gap because you cannot hope to enumerate evil. That's the biggest problem with what you have on threat intelligence. So there's always competing strategies, right? The work that I have done in the past, right, is to try to, I mean, if you only care about false positives, right, we could just write a function like that for you, right? You're never going to get a false positive ever from your thing. So the work that I've been doing in the past has been to try to balance those things. And how do we create analytical techniques and machine learning techniques, I will not say AI, in order to minimize that. So if you want to have a look, I'm not going to talk about this again, but last year I was specifically painstakingly explaining how you try to put all those things together, right? And come across with something that could be mostly automated, right, to do this kind of work. But again, where this thing breaks down is if you don't have the data, right, if you don't have the environmental coverage, right, if you don't have the specific analytical coverage that's interesting for you, right? Or what would be relevant for your specific environment, right? You're just struggling there. You're grasping for straws, right? You're not really going to be finding anything because you didn't do the prep work before to strategically define what should be the priorities of what you're going after, right? So, on the other hand, the cool thing about that strategy that I was talking about on applying machine learning to this idea of hypothesis testing is that you're literally brute forcing the hypothesis space, right? For all different combinations of does this match threat intelligence or not, is this rare or not, is this frequent or not, right? What about if it's on this corner or that corner? You're literally throwing everything against the wall and having a very efficient way to finding out what sticks, right? What's going to stay on that wall, and then suddenly you have a North Star. You found something, maybe you found a hunting lead that then your good analytical people, they can follow up on that thing and hopefully uncover something that hasn't yet gotten your crown jewels, right? You're just in the nick of time there, so it's not necessarily a disaster. It's very hard. I don't know how you guys feel. It's very hard to be work in the threat hunting space because you get most excited when things are the worst, when you really find, oh my God, look what I found here. Well, no, it's actually terrible that you did. But it's hard to take away the excitement. But anyway, as Rob would say, right, these things fail all the time, right? I mean, do you have any good stories for us about like good or bad analytics?
So I mean, even from a machine learning perspective, I'll give you a good example tied back to the safety system one. And I'm going to dime out product pitching because I think that's a good example of where it goes wrong, where there was a vendor in our space, an industrial, that was going around telling people like, we detected Trisis out of the box. No anything needed. We have a machine learning model, and it runs, and we detected Trisis attacks out of the box, no tuning. We would have got it. And I talked to them, followed up, and said, well, that's silly to me because it didn't exist yet, so you didn't know what you were detecting. Are you just classifying an alert as detection? Because that's not realistic. Like an analyst isn't going to be able to pick that up and do anything with it. It's just a contextless alert. And they're like, well, yeah, sure, but we detected it. I'm like, okay, well, let me ask the negative aspect of this. In a case where somebody was on the engineering workstation and interacting with the safety system, when would you have not generated an anomaly? They're like, well, anytime. I'm like, okay, so your detection is syslog. Like anytime somebody accesses that system, you're calling syslog a detection. And this is what I see with a lot of like machine learning driven approaches, is because people aren't marrying up good analyst with machine learning, what ends up happening is it sits in the corner and generates alerts on everything, and then you drown in the alerts. And even worse, and I haven't seen this be a board level topic yet, but one day somebody's got to sit in front of the board and go, did you get the alert? And be like, yes, we got the alert. Well, why didn't you do anything about it? Well, you see, the machine learning is generating a lot of anomalies, and that's going to fail at that level. They're like, no, you got the alert, you did nothing with it, you're fired. Like, these are the things that companies have to deal with in terms of not just tuning, but what are the outputs of having alerts that you're not using today inside of your environment. The other piece where I've seen machine learning effectively highly abused is this an idea that when we start talking about like predictive, like I'm going to start looking for attacks that haven't happened yet, and from those attacks, like I'm going to be able to curate all this data from like OSINT and everything else and tell you that this activity group is going to target you. And what they're effectively trying to get to is what intelligence analysts do all the time. Like indicators are not intelligence. Let's just throw that out. Indicators are the byproduct exhaust fumes of good intelligence work. But intelligence is I'm going to make an assessment about the adversary, usually their intent, opportunity, and capability, and deliver you some new knowledge. Operationally, that would be tradecraft, the methods of the adversary. But strategically, I might have an understanding that certain activity groups operate in a way that they might target me eventually. I'm going to put them into my threat model. But this fails when we start trying to look for characteristics and then inherently predict intent of an adversary. So in other words, I might take a machine learning model, run it across all the attributes related to my environment, run it across all the attributes of known threat actors and activity groups, and be able to come up with an idea that my threat model now is these 5 activity groups based off of what I have. I've seen some companies and some teams start to do that, and the problem is, again, it's also assuming perfect collection on the behalf of you as the analyst and the system. A good example of where human analysis went wrong with that is a couple years ago, there was a campaign called Dragonfly. Symantec did a ton of amazing work on it and said, this is a campaign that's targeting the electric sector. And they highlighted it's targeting the electric sector. And went around and all the media picked up on it and said, if you're in the electric sector, you should watch for this. But what Symantec had is in their collection, they had a lot of electric customers. So the targeting of the electric customers looked like it was targeted towards electric. But they didn't have a lot of mining and petrochemical customers. And it turns out it was also hitting majorly in mining and petrochemical. So based off the intelligence analysis and a misconception of our own collection, the assessment was completely wrong. It was a pretty wide-flung campaign. Circle this back to this discussion, your collection is always going to be a problem. Everybody's collection sucks in comparison to what they think they have. Hell, I mean, I think even like the NSA, it's like, oh, you have all this collection. Nope, like 98% of it's Netflix and porn. You know what I mean? Like it's just a ton of crap collection usually. So this idea that you think you have enough collection to then script it out or using machine learning model off of it is always going to be misleading, and you're going to need good analysts to then understand those gaps. And to me, that's the value of hunting, is finding the gaps in your environment today. To Alex's point, I don't want to go to a board or go to an executive and go, I'm going to go hunting. And if I'm successful, we're going to have a major incident. Like that's not an output that I want to talk about. Instead, I'm going to say, I'm going to do hunting, which is effectively instant response in reverse, and I'm going to make sure that we could reliably detect and respond to these cases. Then I can show a return on investment at an executive level when I go, here are the 5 scenarios that we're covered with today based on our investment against the type of scenarios you're actually concerned with. And with this additional investment, we can extend our automation footprint to cover 6, 7, and 8, and then there's an economy of scale, and we'll actually get 9 and 10 as well. Like this is more of the story that we want to start telling to get security being more impactful in organizations, but it's going to require you to understand your environmental and analytical coverage, and it will always require the human-driven approach to that hypothesis generation and understanding it writ large. Anyway,
Yeah.
sorry.
But I think it touched on a very, very important point, which is the human in the loop kind of idea, right? And the idea that you have touch points where you can engage with a human, and the human can help you actually not only validate what the machine learning model has been able to do, but also take it a little bit further, right? So one of the biggest sins, I believe, that anyone who's trying to build any sort of machine learning-based model does, and this is not just at security, this is everywhere, right, is trying to do too much at the same time, right? Sometimes you have to learn how to crawl, and then you learn how to walk, and then you learn how to run, hopefully. And the idea that you can skip those steps and just do anything at any order, oh, I'm just going to throw this data on a pot and then something magical is going to appear, is usually a bad idea, right? And I brought this example. This is a very interesting work that Dr. Don Song from Berkeley did recently. Was about, I mean, guys, if you see a self-driving car, just run away, right? It's like those things are terrible. And it's how they were, if you just put a few stickers on like the stop sign, right, then it suddenly thinks it's a speed limit thing. But I mean, you guys all understand why we are not fooled by that, right? I mean, if I'm in any country in the world with any language, right, it's not English, right, and I see a sign that's a red hexagon, oh, that's probably stop, right? I should stop. So instead of searching for whatever weird thing that's happening on that deep learning algorithm there to think about that is a stop sign, why am I not just looking for the hexagon? Why am I not doing hierarchical categorization, hierarchical detection? Why am I not finding a small unit of information first, right, which then it's easier for me to understand what it is, and then I can build on that. When I get that validated, I can build on that, right? If I tell this that I told you to the people who actually build those things, they think I'm crazy, but this just makes perfect sense to me, right? If I know that it's always going to be an hexagonal square, I'm not going to be fooled by it, right? And this is really where I believe we can improve the work that we were doing, right? If we have, again, we have our TTP repositories there, right? We have the analytical coverage that I have currently. And, but what if, right? And this is very aspirational, right? I mean, someone actually, we had alerts, we had incidents that we have validated, and they were spot on, right? They were bullseyes. And I offered the bullseyes from my friend David Bianco here. He's wearing his Target red shirt. If I have enough accurate data on alerts that were handled, right? I tell you, I believe we can infer the analytical coverage that we would need in order to find those things, right? And the hard part is getting that data on the left there, right? To actually get people to validate the alerts, right? Even if those alerts are being handcraftedly generated or they're being generated by a machine learning model, right? You know, this is a three magic hat problem, right? This is not a one magic hat problem that we were talking about just before. But I believe if you have enough environmental coverage, right, and you can do enough work in actually validating, right, you can go back and generate the analytical coverage that you have, right? Actually going there, I mean, if anybody ever comes across a system that I made, please give us feedback. We're starving data scientists. We really need your feedback in order to improve, right? But if we had enough data, right, it's really about just pruning the decision tree, right, where the thing seems to aggregate the most, right? So yeah, I really care about finding grapefruits and lemons on my garden. So yeah, I'll just hunt for yellow round fruits. That should be fine, right? I don't actually have to hunt for lemons. I don't actually have to hunt for grapefruits, right? So it just congregates. Everybody uses these kinds of algorithms, right? This is how Spotify suggests stuff for you. This is how Amazon suggests stuff for you. It's called collaborative filtering. But we still don't have enough data, I feel, which is being categorized properly. And this is one of my, every talk that I get is like, guys, of course, crawl, walk, run. If we can get the data orderly, then we can start doing some very, very interesting stuff here, right? Yes, you see, that didn't happen. Nobody heard the word. Become, of course, increasingly better, and again, feed this feed loop. But again, the human needs to validate. You don't want a machine learning model talking to another machine learning model. They will go insane together. It's just a nightmare. But I think we reached kind of an agreement, right?
Yeah, so here's where I would balance the talk out and say, more so than just you must do one or the other, if you are using a machine learning driven approach with detection strategy, in my opinion, you then must complement it with threat hunting so that it doesn't go off the rails. You must complement it with a lead analyst that understand your analytical and environmental coverage. You cannot have a single layered detection strategy for your organization. It's not going to work. In addition to that, I would put forth that also, as much as I'd like to say that sure we can do better than machine learning, and I really don't have a high bar for success for machine learning on this stuff, I will also counter with, I've visited many of your SOCs, I've met many of the analysts. There are some that should really depend more on a machine learning model, because with no offense to anybody, when I go in and say, what do you do if you're a job? Like, oh, the system detects something, it opens a JIRA ticket, I look at the JIRA ticket, if it doesn't immediately stand out, I close the JIRA ticket. Like, that's not machine learning, that's a batch file that you could be automated with, right? Like, it's not a difficult challenge.
You know what? If we just close the JIRA ticket, that guy's job would be gone.
So to Alex's point, the best machine learning model out there is not going to be better than the best driver out there for that car discussion. But it will be better than the 16-year-old texting on their phone. That's where we got to find the balance in terms of how we use automation and hunting. And I would still say it's definitively human, but the gap is closing on what machine learning can actually accomplish for that. Anyways. So.
Yeah, I guess that was it.
And yeah.
Yeah, that's
so I guess we're friends again. Maybe.
I guess we are,
Maybe.
yeah. We'll see next year what happens, right?
Yeah. All right, perfect.
Yeah.
We have no time for, or do we have time for questions? We have no time for questions. We purposely do that, by the way, because somebody's going to ask some good question. I'm going to look like an idiot. I don't want to do that.
Yeah.
So
no,
like,
they're going to make a point. They're not going to ask a question.
Oh, yeah, it's like, I just wanted to tell you that my opinion on this is actually this. Well, that's adorable. All right, so you can find me at the bar. Anyways, thanks, everybody.
Everyone.